start recording for this as well. So we are going into our session 4. Today we're going to go and initially cover conditional statements and how they're done in Python, specifically our good old ifs. We're going to look at ternary operators within that context and how they're managed in Python, and also look at some ways to do a quick assignment of default values if the value is null or truthy in any way. That's going to be the first one, and then we are going to try to cover the sorry guys, I need to do a quick setup. I just realized that I have strings set up here, so I'm going to need to switch over here real quick on my screen. And let me see, is OBS still running? Yeah, OBS is still running. Okay, so we're good. So I'm going to switch the topic below here. CD dot doing quick setup. So meanwhile, go ahead, click the link, and let's jump over to conditionals.py. Then we're gonna do CD, and then we're going to CD. Just need to do a quick setup here, and then do. We're looking for conditionals. 6. So we do. It's going to be update. No. Let's do this. Okay, I believe that's going to set us up. So let's take a look at this real quick. So we're going to switch from strings here to conditionals shortly. I think it takes about 30 seconds to update. And we are going to be looking on our screen in conditionals.py. So as you remember, the way we manage that, we're running in Replit, and we are using Replit config file here. So if you go into that, you want to change that second string from Python strings.py to Python conditionals.py, and let's run it real quick to test. So it started conditionals.py, which is empty. So we're going to be using run button to trigger our tests and everything we're going to be doing live here. In addition to that, if you look at the current topic as conditionals, if you happen to be in Twitch and if you log into Twitch, if you type an exclamation point help conditionals, it will step you through everything in there. So if you're on my webpage and you want to follow this tutorial, if you haven't started it yet, all you need to do is click on, so let me scroll real quick, click on this button here, run on Replit. Once you click it, it's going to pull that particular project from GitHub and set everything up for you. And then you will go into Replit, do Python conditionals.py, and in the Replit, .replit file. And then let's just go to conditionals.py and run it. And Replit, if you're new here, is an IDE that runs in browser, so we will be able to write code in this window here and execute it here, and it's going to play out very nicely for us. All right, so let's start on conditionals themselves. So conditionals, if statements, right? I really shaped this course to be more focused on developers than kind of people new to this, but let's just jump through this anyways. So we have gone through Boolean logic prior to this, so we have looked at various truthiness, right? So it's not just is one value greater than the other. It's not just kind of elements of that, but we also can simply ask if a particular collection is empty by just running if a particular collection, right? And so let's take a look at, let's just do um, basic if statement and just put it in here. If test, we're gonna do this if test print test is true. Let's do uppercase true just for posterity of it, right? So we don't have test defined, so we are going to do something very simple. So again, similar to what we did with truthiness, just to run since we have it, we are going to run an exception because test has not been defined. So we have to have a value assigned to something before we can run this condition. So let's jump back to here, and we're gonna set test equal to true, just a very basic run. And when we run this, we get print test is true. Basic validation that if we put set test equal to false, that print line does not get executed. So in this instance here, we are really running into the first instance of Python scope, right? So with languages that you would be used to, like Java, your scope is managed with squiggly braces. In Python, scope is managed with indentation. So your code has to be pretty for it to work. It's kind of not cute, but it's also reality of Python, which is very nice and convenient and makes it shorter. Ironically, it was pioneered by languages like COBOL, but who is counting? The upside of Python and a little bit of a pain in that sense is that, while in COBOL it was specific column for specific types of expressions and specific scope, in Python you don't have that. So what you have, the way this would work is you would go through and use tabs. That being said, you would have all kinds of conversations about tabs versus spaces. That's one thing. Then is your tab 2 spaces or 4 spaces, things of that nature. So I believe this one defaults to formatting standards. REPL defaults to Python formatting standards, and it is using 2 spaces to indent. Very important notion in scope as well is that if you choose a certain level of indentation for scope, it has to be consistent, right? So if you happen to type another print, offset by 1, I'm just gonna put this is not good and run it. Let's see, it's going to unexpected indent is going to be noted here. And so as you could see, it is very, very relevant for Python how far it goes, and so in here, if I shift it back here and I put this print statement below that is indented in line with if statement and we run it, this is not good no longer. It's true, we'll just keep this is good but outside of if scope. We'll just do that. This is good but outside of if scope. So we're talking about if statement executing test being false, do not step inside the if scope, jumping over executing line 11, running print, the way you would normally expect your if statements to work. However, I really wanted to explore the notion of scope here. As you remember from prior conversation, we have multi-line comment here done by creating a multi-line string, right? And so we have this description here. And we tried out if conditional change value for conditional try again. So we did that, set it to false and kind of played around with that. We took a look at scope here. Just type in C above, just so that we kind of completed that. So if statement with several lines of code, try to execute with conditionals true and false. So that one is just kind of to indicate that, let's do another test underscore test. So let's mess around with truthiness a little bit, right? So let's do another test and make it an empty list, right? Because if we remember, empty list is evaluated to false. So we're gonna do if another test. Now let's do this. Let's do if not another test. Not another test. We are going to evaluate whether another test is empty. So another test, when it's empty, evaluates with truthiness to false. If we set it to a not, it's going to become true. So we're going to do if not, print another test is an empty list, right? So we are looking at an else statement. Let's see. So we're gonna kind of skip the whole multiple lines of code because I talked about the scope a little bit above. That's kind of what that is aiming at. Let's just copy that one into appropriate lineup here below if else here, just to kind of describe what's what. So I'm just gonna drop it here. Okay, so we got this. Now we're gonna do if not another test. We're gonna say this test is empty. So let's run that and see that another test is an empty list. Okay, so we have that happening. So let's now type in else if. So Python shortened that specific thing down to elif, right? Again, we're looking at scope and noting that elif lines up with if in the same vertical in order to be part of the same statement. So elif, I want to check if, I believe it's length of another test. So we're looking here if length of another test is equal to 1. So we're going to check if there is only one element in another test. We're going to print that another test is only one element long. And then we're going to type in just complete else. And in there, we are going to type print another test has multiple elements. So just so you know, right? So if statement after the conditional is terminated by a colon, which indicates that this is the end of the actual if statement. And then once you hit enter, it's gonna, a majority of editors are basically gonna carry you one down and over to the proper set indentation for the scope. And so the same thing here, elif lines up with if, else lines up with all of them as well. And all of the portions of your if, else, if statements end up with a colon indicating this is the end of that statement. So let's take a quick run on that. Another test is an empty list. We are going to add one here. So now our list contains one element in it. We get another test is only one element long. And obviously when we add two, because why not? Another test, sorry about zooming. Let's get out of there. Another test has multiple elements. All right, so I'm going to slow down a little bit and let you guys type it up. One thing I didn't bring up beginning of this session, I tend to bring it up in the beginning of other sessions, is that I do recommend that you run the sessions on two screens, which makes it for easier typing for you. But I'm gonna take a little bit of a breather here and let you finish this up. So next thing we're going to go after is we're kind of going to reflect on a whole bunch of stuff we've done before, and I'm going to sweat bullets here and see that I can do Boolean logic on the fly to everybody, in front of everybody. We're going to put together a rock paper scissors game against the computer. I'm not going to do any kind of manual input, but we are going to just implement it here as we go along. So what we're going to be looking at, if you remember from prior exercise, for starters, we're going to have an NPC that's going to make a move which is going to be choice 1 out of 3 options. Right, so let's start there. If you potentially remember, we're going to go from random import option. So what we're looking at is random functionality that allows you to select a single value out of the list, right? So we played with that before. So what we're going to do, we're going to declare a variable NPC, right? Non-player character that is going to select option from rock, paper, and scissors, and so let's print that real quick just to make sure that I'm doing something meaningful here. So we're gonna do our non-player character. Let's run that real quick. And option is not a thing. I'm trying to remember. Okay, I'm gonna have to Google this. All right, this is not happening for me otherwise. Let's Google this. Python. It's not option, it's choice, of course. All right, so my apologies. It's a wrong name for a function that I've used. Let's do this real quick. Please work. All right, we're better. So we got rock. Let's run the, come on, give me something different. All right, so scissors this time. So we have different choices that our system is making us. So, we're Python and artificial intelligence go together, right? Let's go. Okay, so the next thing, we're going to do a simple thing here. So the first check we're going to verify whether it's a draw. So I'm going to let you type in this one. The basic thing I'm looking for is, let's do user move, and let's make that user move. We're not going to capture it from the actual user. We're just going to assign it paper. Right, so we're going to do all right, so we're going to do user move. We're going to assume is going to be paper, and we're going to see NPC is going to make a random choice here, right? So the first thing we want to do, we want to write is user choice. Let's do if user choice equal to NPC, print it's a draw. So here's your assignment for the first if statement. I want you to kind of go through, see what you just learned, and put one together real quick. So I'll give you a couple of minutes while I'm sipping on my beverage to figure this out. All right. So So let's take a look. The first statement essentially is going to be if user double equal npc print, and let's use our fancy f string and go f user colon squiggly braces user npc colon squiggly braces npc, right? So we're gonna do formatted output. It's a draw. Exclamation point, because we're excited about it. Let's close that and print, and eventually it's gonna choose paper. I probably should have chosen something else, because this is paper is never happening. This is just annoying. Okay, I'm just gonna pick rock because it seems to like rock a lot. I have no idea why it's never dropping on paper. This is now it's just stuck on scissors. Paper. Now it's choosing paper. Come on, rock. All right, finally. So we got a user rock, NPC rock. So it's truly random. AI didn't want us to see our example. NPC rock, it's a draw. Cool. So we got that part going. So let's go and do the following. So next we're going to do else if user so if user move is paper, what we're going to do, we're going to nest our if statements. Else if user move is paper, we're going to go if npc rock print user 1, else npc 1, right? So we're going to do so that we don't have to go through this annoying reprinting user and npc. We're going to print it above here, right? Our quick refactor. So let's do print f colon user move is going to be user, and npc move is going to be npc. So we're going to finish printing that, and here we're just going to print it's a draw. Quick refactor here, quick run. I made a mistake because it decided to help me. Sometimes editors are worst enemies. So let's do another run here. Okay, so we did user move rock, npc move scissors. We don't have any conditions for it yet. So all right, let's take a look at this thing here. So next thing I want to do is else if user move is paper, we're going to exercise these two conditions. If let's see, so if npc is rock, so if user move is paper and npc is rock, then user 1, right? Because paper beats rock somehow. Else npc 1. So I would like for you to go through this and build. Look into that, building that nested if statement. So think about it that you would nest an if inside of if using the same scoped approach, right? So that's kind of why we're doing what we're doing here. So go ahead and do that real quick, making sure we have some time. All right. So obviously for test, for kind of code posterity, I probably should have declared rock, paper, scissors as kind of my constants, so to say, or just variables that don't necessarily get changed, which I didn't, but we got what we got. So let's go with elif, right? So we're looking at elif user move is equal to paper. Let's take a look at what our, so I'm hopping over the comments just so that they are above the lines, but obviously you can just go next line here and kind of proceed. I'm gonna hop over this statement here and go, I'm looking at if npc equals to rock, then I say print. Yeah, the editor kind of helps you with scope of all these things, so it's not too big of a problem. Print user1, and then we're gonna go else print npc1. And I'm just going to simplify all these things, I'm just going to literally copy paste the remainder of this logic just so we kind of to save time here, because it's you know, not terribly you know, not terribly different. So if user sorry, let me just do the proper copy paste here. So I'm grabbing everything up to else if with the comment, and I'm going to, if user goes with paper, so we're going to go with scissors. So if user move is scissors, then we with scissors, if npc moves rock, then we're just gonna go npc1 else, right? If it's scissors, we're just gonna say it's a draw, and so obviously this one is going to be paper for npc, so it's gonna be user1, this one. So if npc is rock, print npc1. And so the last move that we're gonna have here, that I'm gonna just again copy paste 53 through 60, is going to be our rock scissors. So it's the last one is gonna be paper. No, sorry, I did paper scissors, so it's gonna be rock is the last one. So let's copy it here. We're gonna go rock, and we're gonna go rock. No, sorry about that. We're gonna go rock here. So okay, so if rock, then we're looking for if npc is scissors, then we're gonna go user1, and else rock, we're gonna have paper, so it's gonna be npc1. All right, so let's zoom this out so that you can see entire code block. It's pretty massive if else statement with all the comments splattered in between. And yeah, the fun thing with this when you do rapid typing of this is making sure that all your scope got kept in line. It ends up being kind of unwieldy. All right, so let's take a look. So we have user has rock, npc has scissors, user1. We have user rock, npc rock, it's a draw. You have, again, let's not be boring. So user has rock, npc has paper, npc1, right? This is not a trivial one to test, obviously, right? It's because you have the random output, rock versus rock, it's a draw. So it seems like overall it works. And so so we have this setup here. We have this massive if else statement. So we go if they're equal, it's a draw, and then we have the breakdown everything for user, and then the variations for NPC. So that's kind of the breakdown of conditionals and if statements. Let's take a look at ternary operator. So ternary operator, if you haven't used it in other languages, is a way to essentially one line variety of values and evaluations for a condition, right? So if we want to have particular string outputted when we have either when we have some truth statement being evaluated, we get to set either one value or the other. So commonly I'm trying to think of quick example. So let's do out val, I don't know, some kind of output value is equal to this will be true if, and then we have some conditional like I don't know, a test val. So let's do that. So we're going to this will be true, else this will be false. So the key idea there is to assign it to one thing or the other depending on what test val is equal to. So we need to set test val. Let's set it to true. So it could be an actual Boolean evaluation like you would expect in an if statement in here. So if test val is true, we're going to print sorry, let's do, my brain is kind of running out here. So test val is going to be test val, and then we're going to say that out val is going to be out val, and because it's a string and it's kind of goofy, I'm just going to put in arrows before and after it, and let's just run it real quick. Obviously it's a singular evaluation here, so test val equal to true, out val is this will be true, right? So we went into if test val was true, we went and assigned it to the value prior to that. Otherwise this val this will be false is going to be, if we set this value to false, it's going to jump in and say test val is false, out val this will be false. So this, I mean, this example looks super contrived, right? But the common use of ternary is to evaluate if an incoming value is falsy in some way. So this way we can return an alternate value. So we can do something like let's do inval equal to none, right? So we have some instances, for example, a value coming into a function is none, right? We didn't pass anything, and internally we don't have meaningful way of handling none, or none doesn't make much sense for us, and so we want to replace it with, I don't know, for example, an empty list. So we can do underscore val equal to inval if inval is not none, else, for example, empty list, right? So we want to say, okay, we're starting with an empty list, right? So this is one of those cases where you don't want to be handling none because you just want to start working with list, whatever you want to do with it, and all those all those functions that you're running below would handle well an empty list, but they would not handle well a non-value. So what you would end up with here is if you print inval equals inval, right, and then our underscore val is equal to underscore val. I should make it an F string because otherwise it's just going to print gibberish, right? All right, so we're going to do that. I'm going to give you a little pause and kind of let it sort it out. So if inval was equal to none, then underscore val is empty list. So we're going to try out, oops, sorry about that. So what we can do here, we're going to change inval instead of none, right, to check it out. We're going to put none into a list, right? And so as you remember, you can have a list with value none. It's going to be as evaluated to true, right? So now this is kind of madness. But anyway, so if a list is not empty, even if it has a single value that is none, it is going to take that one just fine because it has one element of type none type. So it's going to be crazy here. I'm just going to replace none with something as a string. Something. Something as a string. Okay, and so so now we have inval is equal something, so val evaluated to something. So in that case, the truthiness of inval is not none is true. So we assigned it an inval value instead of an empty list. So on that note, however, there is a shorter way for us to evaluate these kind of situations when we want to reassign a different value if something does not evaluate to truthiness, and that's often done with a none. So I mean, ternary operator is super useful in many other ways. So this was kind of just a simple example to build up to the next step. And so in the next step, if we're looking at a val other, we can do we can evaluate inval equal to empty or a default value in a certain way. So if we put inval here and do or, and then put in the value we desire. And so what's going to happen here is val other is going to be equal to inval or is going to be equal to empty list. So it kind of even shortens the ternary operator here, right? So again, ternary is very useful for a lot of different things, but if you want to do default values, you can actually do it this way. And so what we're going to do here, we're going to do print again our underscore other val. Don't forget we're using an F string. Sorry, other val. Yeah, val other. Let's do val other is equal to val underscore val underscore other. Underscore is, once we get to classes, it's more of a common trend to have an underscore before a private member variable, which is, by the way, not enforced, but anyways, so that's where that's coming from. If you have just a value inside of a function or whatever, you normally don't use underscores, but I just kind of threw this convention in there. All right, so underscore val underscore other, and then we're gonna do in underscore val is going to be equal to in underscore val, closing the double quote here. So right now, if we run this, it's going to lose its mind for a little bit for some reason. Okay, let's hope it doesn't crash on us. So we did something wrong. Inval is not my bad, it has an extra v in there. So inval is not, it is defined, we're fine. So so right now our inval is equal to something. So our, not cal, our val val other is equal to something as well, and inval was something. So if we drop it again and make it empty and run it, we are going to be looking at val other is equal to an empty list, because inval, I'm sorry, so inval was an empty list, so that one's still evaluated to whatever. But if we have this as none, that's where I was going with it. So if we have this one as none, our val other is going to be evaluating to an empty list, just like our val is evaluated to empty list. So this is allowing us to override conditions like none and such. All right, so this one is a conclusion for our conditionals. I'm just letting you guys to like finish typing this thing and kind of absorbing this madness a little bit. So we took a look at default values. We took a look at, crazy if-else-if statement. Yeah, if you ended up messing up that if-else-if statements, obviously just comment out the whole thing for now so that you can continue with the rest of the code, because it would be crashing and preventing you from executing the rest of the stuff. And we have 15 minutes, so I think we can start on our loops if you guys would like. So let's go after that one. All right, so we are looking at let's take a look at our loops. So in order to execute on loops, we are going to, let me see, so it would be 7. So in order to switch over to loops, we're going to go, we're going to be running loops.py. So we're going to go to replit, and we're going to switch this over to loops.py. Let's do a quick run and get, hopefully eventually, an empty list with Python loops.py. Come on. All right, there we go. So we clear this out because we're going now looking at loops.py. There is a lot to kind of look through there. We have our while loop, for loop, and all those things. We're primarily going to be going over for loop capabilities. Again, looking at the loops, the common thing we're going over is progress over a collection of items, repeatedly perform an action until condition is met, perform action a set amount of time, create a forever loop that will keep given program alive, breaking for sleep event, user input, OS input. So yeah, we've definitely, our while true is definitely a common approach to waiting for some kind of events to come in, and commonly used in, somewhere deep in the bowels of the system. If you are using any kind of framework, there's a while true loop running, waiting for things, right? So so these are our while loops in kind of basics of them. So we're looking at 13 minutes. I'm trying to think if I want to jump over the while loop real quick and then just let's go straight into for loop and look through looping over items in a collection. If we want to, the common place for loop in Python is a essentially for each loop, and so kind of the primary approach in Python is to just take a list of whatever or take a collection of whatever and just run through it end to end, and then ability to identify which item is which and which index they're under is more of a secondary capability that does exist in Python, but is not not the first prime citizen. And it's kind of cool. It's just a different approach to it. So if we're looking at our list, let's take a look at our list, and we're going to have just this 1 3 5 7 9 11 13 and then 14, just so we have something 14 15 something a little bit not just odd numbers. So I just made up that list of items there. So if I want to loop over them, all I would need to do is go for. Then I need to indicate a variable I want to have those individual values fed into. So I'm gonna take a L in and then out underscore list. So what I'm saying here is I'm looking for individual elements in out list that I'm going to iterate over. I'm going to then print. So again, colon terminates the for loop statement, and then I have I get indentation which indicates scope. So I go print L equals to, and then squiggly braces L. Don't forget that we're dealing with F strings because we're trying to make things pretty. And we're going to run, and we get this, right? So we get iteration over over a list of things. Okay, so we just iterated over over a list of elements, and we just grabbed every single one of them. We have an opportunity at that to enumerate this element. So if we want to know which number element it is in the list, we have an opportunity to do so. So I'm going to do below, right, indent back, do print, and do let's enumerate. And so what we're going to do, I'm literally going to copy line 14 and 15. Let's bring it below. Sorry, let's see. Control V. All right, and so what I'm going to do is I'm going to call an built-in function that's called enumerate. And the interesting thing, let's just run it and see what it does. So this is weird, right? So it outputs tuple. So when you run enumerate, it's going to grab every element and it's going to output a tuple. First element of that tuple is our index, and the second element of that tuple is the actual value. So we know that we can unroll tuples, right? We can unroll tuples in line here. So L right now, as we printed out, prints out a tuple. If instead of L, I put in, say, I for index, and then I put in L for the value I'm looking for, if I run this again, it returns just that, right? So it returns the actual values because it grabbed L out of this tuple pair. And so now we can go in here. I'm going to put square braces so it looks pretty, and then put squiggly braces so I can print a value. I'm going to put I in here, and I'm going to run this again, and I get this is my index, these are the values. So I have an opportunity to get an actual index. I don't need to do the, hey, run for loop for length of this thing, and then get, iterate until the end of the length, right? So the normal for loop that would write in other languages, here we have an opportunity to just say, go through this thing, and then go, by the way, I actually want to know the number of each individual thing. And then I go, well, while I want to know the number, I also want to, I want to grab it, I want to print it. And so you have an opportunity to enumerate through the list if you have index values that are relevant to you. So let's see where we are on time. Let's do loop over items in a dictionary. So we can take a dictionary apart and we can grab the name and value pairs, right? Or a key and value pairs out of it and iterate through that. So that one is actually quite important tool to use for a variety of reasons. So let's just jump into it. So if we look at out list, not out list, out dict, right? So dictionaries, we are of type dict is the name for the type. So squiggly brace. Here, let's do 1 and let's do first, right? So we're defining our dictionary in line. So key colon value comma next key 2 colon, I'm just going to put value 2, right? Because we can have this, whatever values we want to have for both for values and keys. So 1 2, let's do 3 colon 3.1 just because I feel like it, and then we do 4, let's do it like lowercase 4 just because, again, and it's going to be true just because we have to have a boolean somewhere here. So now we have our dictionary with 4 elements and 4 keys in it, and we are able to iterate through that using a for loop. So let's go 4, and I'll just leave a value for now, v of some sort, right? So what we're doing here so let's see what happens if we do out underscore dict, right? And let's do print v. I'm just gonna be super lazy. Before all of this, let's just, for distinction purposes, let's do print loop through dict. So we just can see the line in the sense, sort of. So if we do this, let's run this, see if it does anything. So interestingly enough, it does. So Python goes like, well, you want to iterate through a thing, I can give you something. So what it's going to give you out of the gate is going to give you just bunch of keys by default to run through. So that's something, right? Well, we actually want to see both keys and values. So the way you would do that is there is an embedded function in dictionary that is called items, and let's see what that returns. So that returns tuples, which are first element is the key, second element is the value. Again, a tuple could be unrolled, so you can go with k comma v, right? So now what we're doing, we're saying k is going to be a key is going to go into k, and value is going to go into v. So right now, if we run it, we are just going to print values, first 2, 3.1, and true. And so then let's make it pretty. So we're going to go f key is going to be squiggly braces k, and value is going to be v. And so we are going to now run this dictionary through, and we're going to say, you're going to print out our keys, we're going to print out our values, and we're going to be done with this. So we're going to take a look at range next time, and we're going to dive into the world of list comprehensions, dictionary comprehensions, and into kind of embedded true power of Python. So that's going to be next time. And until then, thank you very much, and we shall see you later.